The aquaculture arena, filling the gap. The sea is a major source of food, as well as being the largest source of animal protein consumed in the world. Natural fishing by means of fishing fleets is the last major world industry which exploits uncultivated natural food resources. The total volume of fish caught annually is estimated at 100 million tons. This has remained static for the past 2 decades because of intensive and indiscriminate overfishing, which has steadily diminished the marine population. Development of advanced fishing technology using radar and satellite tracking devices enables fishing vessels to maneuver accurately into areas where fish congregate to feed and breed. The rising demand for marine protein has resulted in the constant decline in availability of fish from natural resources. Many of the valued seafood types are on the point of extinction. This has decreased the value of the catch. The global consumption of fish per capita has increased in proportion to the increase in world population. An increase in the global consumption of fish will accelerate as consumers become increasingly aware of the mostly uncontaminated nutritional value of marine protein. This is especially apparent in the steadily growing trend to substitute healthier seafood for red meat and other animal products. It is also escalating because of the spiraling increase in world population, especially in that of the underdeveloped emerging economies. There is an escalation in the gap between demand and supply, which will intensify pressure on the seafood trade and inflate prices, which have risen much faster than the prices of the meat or poultry products over the past 20 years. The present global consumption of marine protein is 13 kilograms per person per annum. To maintain this figure, the United Nations Food and Agriculture Organization estimates that another 19 million tons of marine protein will be required to sustain the estimated world population of 7 billion in the year 2010. If the current level of supply by the world fishing industry can be sustained, the shortfall will have to come from aquaculture, which means doubling today's yield. Aquaculture is the husbandry of aquatic animals and plants. It continues to grow in economic importance worldwide as it bridges the gap between the demand and supply for marine products. By the year 2000, the world aquaculture production is estimated to reach 22 million tons. This will provide 25% of the total seafood production and consumption. Aquaculture is expected to continue its rapid growth as restrictions on harvests of natural marine life are more stringently imposed and consumers become even more aware of the nutritional and health benefits of seafood consumption. Experts estimate that by the year 2005 there will be a global shortage of 15 million tons of fish. The only feasible way to take up the shortfall is to ensure that the aquaculture production is doubled within the next 15 years. Intensive aquaculture systems in cages in the sea form the fastest growing segment of aquaculture, and it is within this framework that the future growth is expected to take place. Aquaculture systems in the sea offer the following advantages. There would be a continuous supply of seafood, which is fresh 52 weeks of the year. There would be a constant supply of seafood in a range of sizes and different product forms. There would also be an assured constancy of quality. The integration of supply and distribution on demand would expedite marketing and delivery. There would be stabilization of prices. Choice of product as desired would be assured. As a market-driven enterprise, it would ensure sustained profits. Why fish farming in the sea? and fish culture in cages. The next logical step for aquaculture to pursue is to utilize the seas and the oceans. The critical reasons for this are summarized in the disadvantages associated with inland aquaculture. There is limited development potential for inland aquaculture projects because of a number of factors, which include lack of available sites, shortage of water, limited access to water resources, environmental restrictions on wastewater discharge, high investment cost, high operating costs connected to water recycling, oxygen injection, waste management, high risk because of technology which aggravates diseases. Therefore, the development and growth of intensive inland industrial aquaculture operations are limited and burdened by a variety of factors. The most serious one is a very restricted supply of fresh water. In view of all the above disadvantages, the only available places to turn to for viable fish farming in cages are the seas and the oceans, as the Earth's surface comprises 68% of seas and oceans. For all countries which are fortunate to have a long coastline, marine culture is the most logical and rational solution for seafood production problems, as well as a solution to the critical global food and protein shortage. Other imperative reasons to harness the sea for intensive industrialized aquaculture projects are economic and environmental. Intensive aquaculture involves constant circulation of water in the farming biosystem. An open system requires the discharging of water with animal waste into the environment, which is a threat to the ecosystem. Massive construction of ponds, which would occupy limited valuable agricultural land, is another disrupting factor to the environment. All these problems are avoided in marine culture. The sea provides an unlimited supply of fresh water. The currents are constantly washing away biological waste, and there are no physical constraints on the size of the operation. Sea fish are far more palatable. After the initial cost outlay, operational costs are cheaper than costs of inland systems. The industry's evolution would be the trend towards offshore, open ocean fish farming. Governments and businesses worldwide, where the fishing industry has received a severe setback, are looking to promote new technology and the establishment of innovative projects in aquaculture to create new sources of revenue for their diminished fishing industry. This situation has resulted in the development of marine culture technology for controlled fish farming in the sea. For the past 10 years, the technology for fish farming in cages in the sea has mainly been developed for farming in protected waters and calm bays in inshore cage systems. This solution also presents major environmental hazards, such as polluting the bay water. The cage fish are also subject to pollution from effluent discharge close inshore, which causes disease and reduces the oxygen levels in the water. This is evident in the Scandinavian countries where salmon are bred, and in Greece and Spain where fish is farmed in cages in protected bays. In many countries, influential environmental groups are actively advocating a drastic reduction in fish farming in coastal waters to reduce its damaging ecological effect. Because of environmental conditions, competition with other users of the coasts, and difficulties with people building homes and hotels jutting into the sea, and marinas, Coastal marine sites with the appropriate aquaculture conditions are becoming scarcer in the United States of America, Europe, and Japan. This places a serious limit on the growth of the coastal aquaculture industry. Because these technologies are limited to the shrinking coastal bay sites protected from rough seas, expansion into other areas is essential to overcome the increasing shortfall between an ever-growing demand and a dwindling fish supply. For the aquaculture industry to expand, there is a need to migrate much further offshore. Offshore fish farming projects offer the following significant advantages: access to large bodies of water far enough away from the shore but close enough to ports for logistical purposes, reduced interference and competition with coastal development and other existing inshore fisheries, lower risk of transfer of parasites and disease organisms. The density of fish stock in offshore sites can be 2 to 4 times greater than in inshore systems. There are much higher dilution ratios for biological waste. There is far lower oxygen stress on fish. This all results in tastier, superior quality fish with less fat content, which is more appealing to consumers. The immediate economic advantages of the offshore system over the inshore one is the stock biomass density. In offshore cages, the density of fish per unit of volume can be significantly greater than in inshore systems. Greater density means less in initial investments and operating costs, while the profits are larger. The disadvantages of inshore cage farming, according to a survey of fish farmers in Norway and Ireland, includes reduced growth after 3 or 4 years in one location, increased occurrence of disease after 3 to 5 years, large variations in resistance to disease between different generations, unpredictable and variable physical development of the fish and different growth rate. Offshore fish farming in cages. In the past 5 years, a few companies have been trying to develop the technology for offshore fish farming in cages as an alternative to the limited potential and myriad problems of cage technology in protected bays. In the past 5 years, a few companies have been trying to develop the technology for offshore fish farming in cages as an alternative to the limited potential and myriad problems of cage technology in protected bays. It has been proved that an unlimited amount of fish can be farmed in the open sea, with significant advantages over fish farming in protected bays with respect to ecology, disease level, and most importantly, cost. One of the major problems of offshore fish farming in cages has been contending with the natural forces and elements at work on the cages and the fish in the open sea. During a storm, waves and strong currents can cause irreparable damage and breakages to the cages, resulting in the loss of some or all of the fish. However, with our newly developed technology for ocean cage systems, these problems have been eliminated. The cages are submerged to a level below the surface of the ocean where they are unaffected by the surge of waves, currents, or storms. They are situated sufficiently high above the ocean bed to avoid any adverse effect on the fish or the cages by any pollution settled there. The cages are anchored in such a way that it is impossible for them to break loose and crash to the bottom. The cages can be raised and submerged in such a way that the appropriate rate of decompression is maintained, and they are easily towed to a new location. The future of offshore aquaculture is a promising growth industry. With the ever-increasing shortfall in the world's fish and seafood production, this enterprise will assure investors of satisfying profits for a long time ahead.